Hello pre-calculus students, and welcome to the second video in our series on the mathematics of finance. And in this video we are going to talk about annuities and what that really means. So in the previous video we talked about what happens. I'll show you the problem if Jill invests $25,000 with an APR of 8%. Okay. Now in real life it is kind of difficult to just have $25,000 to invest. Most people don't have that kind of money laying around. So what actually happens is that you invest a little bit at a time. In other words, a sequence of equal periodic payments. So you you invest a little bit at a time instead of a massive or a large sum like this of $25,000. Okay. So let's look at this scenario. Every quarter, Jack invests $500. He invests his money at 8% interest, compounded quarterly. How much money will Jack have in 1 year? And a few key words here. First, it's every quarter he puts in $500, and then his money is compounded 8% compounded quarterly. So let's work this out here. Okay, and this is a slightly different scenario than everything else we've been dealing with. So let me kind of illustrate by quarter. So at quarter one, okay, Jack has $500. He puts $500 in there. And since he just put it in, it hasn't earned him any interest whatsoever. Then at quarter two, okay, this 500 has earned a little bit of interest. It's $500 times 1 plus 0.08, because that's the APR, or the interest rate. It's compounded quarterly, and it's only been 1 quarter. It's not been a full year yet. It's only been 1 quarter, so that's all he has. Okay. However, this is the money that he has left over from the previous quarter. Okay. So I want to make a note here. This is quarter one has earned interest. Okay, so this $500 is the $500 he put in from quarter one. Now it's earned a little bit of interest. And then what he does is he puts in another $500. So the first $500 has earned a little bit of interest. The second $500 hasn't earned anything yet. So that's the end of quarter two. Quarter three comes around, and the original $500 has earned a little bit more interest because it's been in there for 2 full quarters now. So this one here becomes a 2, okay? Because it's been in there for 2 quarters now, quarter one and quarter two, so it's got some interest. This amount of money, the $500, this has been around long enough to earn a little bit of interest. 1 plus 0.08 divided by 4 to the first power. Okay, so the original $500 has been in there for 2 quarters, hence the 2 here. The second $500 that he put in quarter two has only been there for 1 quarter, so this is the total amount that he gets. But again, remember, an annuity is a sequence of equal periodic. It means he's going to put the same amount in again. So now he puts in some more money, and he puts in another $500. That marker is dead. Let's see, he puts in another $500. Okay, but because he just put this one in, it hasn't earned him any interest. And we'll go one more quarter since it's asking for a year. So at quarter four, this becomes 500 plus 0.08 over 4 to the third, because it's been here for 3 quarters now. This amount here, the amount in green, becomes 500 times 1 plus 0.08 over 4 to the second this time, because it's been in here since quarter two. It's been 2 quarters now. This amount here has been in here, the one in red, which is the 3rd quarter investment, has been in here long enough for him to earn a little bit of interest. Oops, let me zoom out here so you can see this. And then finally, he's going to put another $500 in at the end. So if you add all of this amount up, you will see how much money he has made in the first year. So it's 500 times 1.02 to the third plus 500 times 1.02 squared plus 500 times 1.02 to the first plus 500. So $2,060.81. So at the end of 1 year, he has about $2,060.81. And just for us to check our sanity, a good way to check would be to say, what if he didn't earn any interest whatsoever? How much money would he have? Well, he would have 500, 1,000, 1,500, 2,000. So if he had no interest, he would have had 2,000. He's got an 8% interest, so he earned $60 more. So at least this number makes sense, even if you made some sort of arithmetic error. Okay, but you can see how this problem gets really complicated. Let me show you the second question here that says, how much will Jack have in 5 years? Okay, well, if we continue this is year 1. Let's continue on to year 2, just so you can see. So in year 2, we'll call this quarter 5 now. Well, he's got the original amount, 500. This time, this amount is going to be raised to the 4th because it's been in here for a full year, plus 500. This amount here, it's going to be raised to the 3rd. The amount in red is going to be 500, 1.08 over 4. It's going to be squared because it's been here for 2 quarters now. It's been in here since the original, the quarter 3. So this is quarter 5. It's been here for 2 quarters. And this amount that he added in last time earns a little bit more interest as well. And then he puts in another $500. So you can see how this problem becomes more complicated. And you can go quarter 6, quarter 7, all the way up to quarter 20, because we're talking about 5 years. And the computation here becomes quite tedious, and especially for most annuities are done over the course of about 10, 20, 30 years. It's usually people's retirement funds, usually at home loans that when people take out loans to try to borrow money to buy a house. So this computation gets quite tedious. Fortunately, there is an equation for this, and later on when we get to sequences and series, I will explain it, in fact derive this equation, and you can see where it really comes from. But for now, I'm going to show you this equation. I'm going to explain what some of these values mean, okay? And then we'll go back to the problem. Okay. Before we get into the equation, I just want to highlight one very important thing here, that this is only for an annuity. Okay? This is the future value of an annuity, and this equation only works if we are talking about an annuity. Every year I get students who apply this equation here to other problems where it's not an annuity, and it's somewhat tragic. All right, so this is the future value. FV here stands for the future value, which is how much money are you going to have. Big R is the periodic payment amount. Little r is the APR, or the interest rate. K is the number of times compounded each year. And then finally T is the time in years. Okay. And once again, deriving this equation is very, very satisfying, and we will get to it later on when we get to sequences and series. But for the moment, unfortunately, we're stuck with having this equation and having to deal and just using it. Okay? But it can help us quite a bit, and we can get a lot done with just this equation. So let's go back to our problem here where it says, how much will Jack have in 5 years? Okay. Well, in this problem, Jack is investing $500. So big R is 500. He has an APR of, says here, of, let's see, 8%. So little r is 0.08. It is compounded quarterly, so K is 4. And the question is asking for a period of 5 years, so T is 5. And now it's a matter of just using the equation. So the future value, in other words, how much he's going to have in 5 years, and again, this is the future value of an annuity. This equation does not work for any other types of future values. It is 500 times a fraction, which is 1 plus R over K raised to the KT, so KT 4 times 5. That whole thing minus 1 and divided by 0.08 over 4. Okay. And you know, this equation seems simple, and it really is. You just have to be very careful when we type this into our calculator. So I'm going to go really nice and slow with this. So I'm going to start with the innermost part of the parentheses. 0.08 divided by 4 plus 1 raised to the 4 times 5, or to the 20th, minus 1 divided by 0.08 divided by 4, so just put parentheses here, 0.08 divided by 4, and then that whole thing multiplied by 500. And my answer is that Jack, in 5 years, he has about $12,148.68. And we do want to make some sense of this. Again, just ask yourself, if he just puts in $500 every single quarter without any sort of interest, how much money would he have? Just as a good way to check. Okay. With no interest, all he's really doing is putting in 500, and he's doing this 500 every quarter, 4 times a year for 5 years. And let's just check that makes sense. So 500 times 4 times 5, that's 5, not times 8. You know, he would have $10,000. Okay. This is with interest. He has $12,148.68. So clearly, this problem, at least it makes sense. He's earning a little bit more here than he would have if he did this with no interest at all. So the main takeaways that you should get from here is what an annuity really means, the complexity that it's involved when we try to calculate the value of an annuity, and how to use the equation that I gave you earlier for calculating the future value of an annuity. Once again, thank you for watching. Have a wonderful day.